Welcome to lesson 47 of course 2. In this lesson we're going to deal with powers of 10. We're going to use powers of 10 to show place value. We're going to write numbers in expanded notation using powers of 10. We're going to multiply by powers of 10 and we're going to divide by powers of 10. We do not have any new vocabulary, so let's get started. The positive powers of 10 are easy to write. The exponent matches the number of zeros in the product. So 10 to the second power is equal to 10 times 10, or 100, or 1 with 2 zeros. 10 to the fourth power would be 10 times 10 times 10 times 10, or 1 followed by 4 zeros, which gives us our 10,000. So observe what happens if we multiply or divide powers of 10 or find the power of a power of 10. If we multiply powers of 10, the exponent of the products equals the sum of the exponents. So 10 to the third times 10 to the third is 10 to the sixth. That's 3 plus 3 equals 6. The way you see that is that 10 to the third is really 10 times 10 times 10, which is 1,000, which is also happens to be a 1 with 3 zeros. And if we times that by itself, then we get 1 with 6 zeros, or 1 million. So when we multiply powers of 10, we add these exponents. When we divide powers of 10, we subtract them. So 6 minus 3 is 3. So 10 to the 6th, or 1 million, divided by 1,000, which is 10 to the third power, is equal to 1,000. Because we know that there's 3 zeros, there's 3 zeros, those 3 equal 6 if we go back the other way. So when we add powers of 10, when we multiply powers of 10, we add the exponents. When we divide powers of 10, we subtract. Okay, so if we find the powers of 10, the result is the power of 10 is the product of the exponents. So 10 to the third to the second power. So we're not adding, we're multiplying here. So that is really 10 to the sixth, because 10 to the third to the second power is really 10 to the third times 10 to the third. And we know that when we multiply exponents, we add them. So it's 10 to the sixth. We also notice that 3 times 2 is 6. So the rules of exponents are that a to any exponent times a to any exponent equals a plus the exponent. You add those exponents together. If we're dividing, we subtract them. And if we're getting a power to another power, then we multiply them to get our answer. So if we had, let me give you an example. If I had 10 to the fourth times the second power, what would that equal? 10 to the eighth. It would be 4 times 2. All right, so let's look at some important things about exponents that you need to always keep in mind. Let's start with this one right here. Any number other than 0 with an exponent of 0 equals 1. So 10, or let's say 18, and we have an exponent of 0, 18 to the 0 exponent is equal to 1. Any number with 0 to the 0 exponent is equal to 1. So 4,837,000 to the 0 exponent would be equal to 1. Important rule to remember. Another important rule to remember is this one here, that any number with an exponent of 1, so let's do 18 of 1, is equal to itself. So 18 to the first power is 18. 18 to 0 power is 1. Now 0, whenever you have 0 with any exponent, even this exponent was 59. 0 to the 59 is still 0. Right? It would still be equal to 0. So let's look at this. 0 to the 0 exponent would be equal to what? 0. Because any number other than 0 with an exponent of 0 has a value of 1. but 0 to the 0 equals 0, or undefined maybe. 135 to the 0 is equal to what? It's equal to 1, because it follows up here in this rule here. 334 to the 1 power is equal to itself, which is 334. 0 to the 1 power is equal to 0, because any number with an exponent 1 has the same value. 6983 to the 1 power is equal to 6983. And 98,445 to the 0 power is equal to what? That is equal to 1, again, up here. Hopefully you got the so hopefully you're able to do that. So we had the first one, the 0 to the 0 is equal to 0. The 135 to the 0 is equal to 1. 334 to the first power is equal to 334. 0 to the 1 power is equal to 0. And 6,983 to the 1 power is 6,983. And 98,445 to 0 exponent is equal to 1. I know it's a lot to remember, but those are important rules, and you'll get a lot of practice in these. Okay, find the missing exponents. So let's take a look at these. What's our rule when we're multiplying? In A, 2 to the 4th times 2 to the 2nd says that we're supposed to add our exponents. So it's going to be 2 to the 6. On B, when we divide, we subtract our exponents. So 2 to the 4th power divided by 2 to the 2nd power is going to be 2 to the 2nd power, because 4 minus 2 is 2. Now, this one here, C, whenever we have a power to another power, we multiply those two. So this 2 to the 4th is really 2 to the 4 times 2 to the 4, right? So it's going to be 2 to the 8. Not 2 to the 6. Don't write down 6. It's 2 to the 8. Because it's 2 to the 4 power plus times 2 to the 4 power, and we know that we add those together to equal 8. This is a great way of showing you how that subtraction works. Because you got 2 to the 4th power on top and 2 to the 2nd power on the bottom, and then when you cancel them out, what are you left with? 2 to the 2nd power. That's a great way of showing it. I like that. And here, kind of the same thing. 4 plus a 2 equals 6. So right, here's something that you've maybe gotten away. Expanded notation. You remember what expanded notation is? 5,206. Normally you'd write 5 times 1,000. That would be plus 2 times 100. You know, we'd keep going. That's expanded notation. See if you can do it using the powers of 10. And some of you did this before when you're supposed to do it like this. You did it with the powers. So what would that 5 really be? That would be 5 times 10 to the, how many zeros do I have? 3 plus 2 times 10 to the 2nd, right? And then we finish it up. Plus 6 times 10 to the 0. Which is equal to, again, what? 1. And 6 times 1 is 6. Multiply 46.235 times 10 to the 2nd power. This, you know that 10 to the 2nd power is going to add how many zeros? 2. So we can just move our decimal. Or what we're really doing is we're taking this 4 in the 10th spot and we're shifting it over 2. So you end up with 4, 6, 2, 3, 5. But then our decimal becomes right here. So I like to do it where I just move the 2 over, decimal over 2 when we're multiplying. You can guess what we do when we divide. We go the other direction, right? So that's how that's the way I like to just move it 2 to the right. Anytime you see it by a power of 10 like that, you can just move your decimal If it's a positive number, move it to the right. Right, 2.5 billion in standard form. So this is just writing it out. Not in expanded. So you've got, which is 2 5 0 0 0 0 0 0 0 0. Is that what we got? There you go. This is expanded notation using powers of 10. This is the actual standard form. Throw in your commas. All right. To divide a number by a positive power of 10, we shift the decimal point to the left. So divide this. You take 3.5 and you're going to move it to the left. How many spots to the left? 4. 1, 2, 3, 4. Put in your zeros. There's your answer. 0.00035. Pretty easy stuff once you get the hang of it. I know it can be a little confusing the first time you see it. Watch the video a couple times if you need to. There's your TIDs for tomorrow or for tonight. We'll work on the lesson tomorrow. If you have questions, bring them. Please submit these so they're not late, and we'll see you in class tomorrow.